Hi, in this video we're going to talk about inverse functions. So if you remember from arithmetics, we have additive inverse and multiplicative inverse. So the idea is if you have 5, yeah, and if you add the inverse of 5, which is minus 5, you end up with 0. So for any number given, if you add its inverse, you find 0. That's called as the additive inverse. And what happens in multiplication is that if you have 3 and you multiply it by 1 over 3, which is its multiplicative inverse, you end up with 1. So for any value given, if you end up with 1 when you multiply it with another number, then you can say that these two are multiplicative inverses of the other. So 3 is the multiplicative inverse of 1/3, and 1/3 is the multiplicative inverse of 3, and so on. Now we have the same idea in functions. So basically, for a given function f, if you write the composite function with its inverse, you always find the identity function, which is x itself. Alright, so the function and its inverse, if you compose them, if you write a composite function out of it, like this, you end up with x, right? So, we need to be finding the inverse of a function, right? Here is how. So, given the function being 3x minus 7, function f, find the inverse of the function. So you can see that I denote the inverse with a negative first power. All right, this is the inverse of the function f. All right. Now remember, one of the notations for functions is that you can write them as y equals 3x minus 7. This is how I'm going to start. The first thing I'm going to do is to swap the variables. So it's going to be x equals 3y minus 7. And then I will start working on this to leave y alone. When y is alone, when I find y equals something, that expression will be the inverse function. So let's play with this now. I'm going to go like x plus 7 is 3y, and obviously I'll divide by 3 both sides. So I'm going to have y to be x plus 7 over 3. So basically f inverse of x, right, will be x plus 7 over 3. That's the expression for the inverse of the function f of x. Let's see another example. So let's have this time f of x equals 2x squared minus 3. Fine. I'll start writing it as y equals 2x squared minus 3, and then I'll swap the variables, so it's going to be x equals 2y squared minus 3. Then I'll start leaving y alone, so it's going to be x plus 3 equals 2y squared, and then I'll divide both sides by 2, so y squared will be x plus 3 over 2, and then, well, I need y, so I'm going to take the square root of both sides, right? And then I'm going to end up with y equals square root of x plus 3, that's not a nice 3, all right, x plus 3 over 2, right? So this is my inverse function, so I have to write at the end f inverse of x is x plus 3 over 2 in square root. That's my inverse function. Before I move on to another example, I'd like to show you the relation of inverse functions with domain and range. Now remember, a function is defined from the domain to the range, right? Now, if I define the function f from the domain to the range, the inverse function is defined from the range of f to the domain of f. But of course, an inverse function is just another function, so for that inverse function, the range here that we're talking about is the domain of the inverse function, right? And the domain becomes the range for this inverse function. So although we are talking about the same two sets, right, the names change according to which function we are talking about. For the function f, domain is this set, range is this set. For the function f inverse, the domain is this set, range is this set. So they just swap, okay? Now, this is very important because what happens is, let's say I have a value here in the domain, and this value is mapped to f of a, right? Because whatever f is, I substitute the value of a, and then I calculate it, and then I find the image. Now, for the inverse function, all right, it works backwards, all right? This is the value that I substitute to the inverse function. So what happens is, I substitute f of a into the inverse of the function, and of course it will map back to the value of a. Now we're going to use this idea while finding values with the inverse functions. Let's see an example. Right, let's look at this question now. It says, given f of x is 7x minus 6, find the value of f inverse of 15. Now, the first way, right, is that you can find the expression for the inverse function, and then you can substitute 15 into the inverse function and find that it's actually 3. That is the first way. I think this way is a little bit too time consuming, especially if the given expression is not linear. If you have a quadratic expression, cubic expression, it will be slightly harder to end up with the inverse function expression. My suggestion is, of course, if the question is not asking you to find the expression for the inverse function, if they're just asking a value for the inverse function, my suggestion is to consider what our discussion was in terms of domain and range. Now, obviously, there is this function f defined from the domain to the range, right? And there is this value which is mapped into 15. And for the function which is defined as the inverse function, right, we are now asked to reverse that mapping. And we're going to substitute it into the inverse function and find it back. But this means that somebody, probably the writer of the question, has already substituted the function. So what I'm talking about is there's this a value, all right, which gives you 15. And of course, they're now asking us to find that a value, right? So what is a? That's the question. So what I'm saying is, if I consider a being substituted into the function f, I'm going to have 7a minus 6, isn't it? So I have a substituted here, right? So this must give me 15, all right? So basically I'm going to end up saying that's going to be 7a minus 6 equals 15. And here, 7a is 21, and a is 3. Let me repeat. We are asked to find a value substituted into the inverse function, which means that I'm reversing the mapping. So basically, I'm trying to find this a value in the domain of f, which gives 15. So if I substitute that a value, right, into the function, I must get 15. And that's the substitution, right? Instead of x, I write a. So what I'm talking about is 7a minus 6 must be 15. And from here, I can easily calculate the value which is asked. So I can end up saying f inverse of 15 is 3. Why? Because f of 3 is 15. Can you see the relation? So these are swapped because basically the domain and range is swapped. So you can just write a simple equation. Even when it's quadratic, it's going to be easier to solve than the first way, right? And you can just find the answer. Right. Now, in this set of exercises, we have 4 questions. The first 2 of which you have to find an expression for the inverse function, and the latter 2 is just finding a value. Now, for the last question, I wrote this, where x is greater than 0, because when you try to find the answer, you will end up with 2 answers, one of which will be negative. I want you to exclude that. It's going to be only the positive value, all right? Okay. So, please solve these on your books and submit your answers online. Thanks for watching.